experiment wants to figure out how cookie and butter affects its taste. Therefore, the main ingredients, which are variables in the case, are cookie and butter. Other ingredients include milk powder, cranberry, marshmallow, nuts, and dried strawberries. The first step to make snowflake crisp is materials preparation, such as weighing ingredients and cutting nuts and dried strawberries. Then put marshmallow into the pot, heating and stirring until melt into liquid. Pour other ingredients into the pot together and mix these ingredients. The next step is to put materials out of the pot. Before cooling at room temperature, the materials are shaping into cuboid by pressing. The list of customer requirements consists of fragrance, sweetness, crispness, thickness. The importance are 5, 4, 5, 3 respectively. The listing of technical design elements are butter, biscuit, marshmallow, nuts, and shaping. Finally, we prioritize technical requirements by ranking calculation results.
In order to check how the changes made in the recipe of snowflake crisp will affect the customer's decisions towards flavor, and find out the best ingredient composition that optimizes the taste, we designed the following experiment. There are two major ingredients of making snowflake crisp, which are butter, mainly affect the fragrance, and biscuit, mainly affect the crispness. Each variable has two attribute levels. For the butter, 15 grams versus 20 grams, and for the biscuit, 40 grams versus 60 grams. By controlling the amount of butter and biscuit, we could change the fragrance and crispness, and thus the flavor of the snowflake crisp accordingly. So here's the raw data of the experiment. We have made 4 trials in total, and asked 10 respondents to give each trial a score after they tasted the 4 snowflake crisp with different ingredient composition. Then we use the average score of each trial as the dependent variable. Then we ran the data, and here are the Minitab outputs. Firstly, let's look at the Pareto chart of the standardized effects. It's obvious that both factor A and B and their interaction have passed the red line, which means that all of them are statistically significant in affecting the taste of the snowflake crisp. From the analysis of variance table, we can see the p-value of the model is less than 0.05, meaning that the overall model is useful in prediction. Additionally, the model summary table shows an adjusted R-square of 61.52%, which tells us that 61.52% of the variance of the response, that is, the flavor of the snowflake crisp, could be explained by this model. Then let's take a look at the main effects plot for the score. Obviously, the slope of biscuits is much more steeper than that of butter, and thus biscuit has a greater effect on the score than butter. And for the interaction plot, we can see the lines of biscuit and butter are not parallel, which means that they have an interaction with each other. Also, from the coded coefficients table, we can see the p-values of the variables are less than 0.05, indicating that they are useful predictors in this model. Therefore, we finally generated the regression equation, which is Score equals to 107.7 minus 0.585 times biscuit minus 2.3 times butter and plus 0.056 the interaction of biscuit and butter. Eventually, we did a model evaluation. From the QQ plot and the histogram in the left-hand side, we can see the residues are roughly normally distributed. Also, the two charts on the right-hand side tells us that the residues are with a mean of 0, a constant variance, and no time series pattern. So we can finally draw a conclusion that the overall model is useful and acceptable.